This is the 2018 MEXT Undergraduate Mathematics B paper. Section 1, Number 1. In this question, we are told that both x and y are positive, and the equation x plus 3y equals 2 holds. First of all, let's rearrange the terms of this linear equation to find the slope and the y-intercept. So the graph of this linear equation looks like this. And because both x and y are positive, we are dealing with this segment. In this section, the product x times y should be maximum at the midpoint here. 1, 2 over 6, which is 1/3. Since the maximum value of x times y is 1/3, the minimum value of 1 over xy must be 3. Number 2. We need to find the value of x. 2 raised to the power of x plus 2 is 2 raised to the power of x times 2 squared. And 2 raised to the power of minus x is 1 over 2 raised to the power of x. So let y be 2 raised to the power of x. Then the above equation can be rewritten as 4y minus 1 over y plus 3 equals 0. Let's multiply each term by y. Let's use the quadratic formula to solve this quadratic equation. So y is 1/4 or minus 1, but remember that 2 raised to the power of x must always be positive, because the graph looks like this. Therefore, 2 raised to the power of x must be 1/4. So what is the value of x that satisfies this equation? 1/4 is 2 raised to the power of minus 2. So x is minus 2. Number 3. In this question, we are told that this polynomial is divisible by this. So let's first of all divide this polynomial by x minus 1. X cubed times x is x to the 4th power. X cubed minus 1 is minus x cubed. A minus minus 1 is a plus 1. A plus 1 x squared times x is a plus 1 x cubed. A plus 1 x squared times minus 1 is minus a plus 1 x squared. Now, what is a minus minus a plus 1? 2a plus 1. 2a plus 1x times x is 2a plus 1x squared. 2a plus 1x times minus 1 is minus 2a plus 1x. b minus minus 2a plus 1. 2a plus b plus 1x. 2a plus b plus 1 times x. 2a plus b plus 1 minus 1. Minus 6 minus minus 2a plus b plus 1. 2a plus b minus 5. And because this polynomial is divisible by x minus 1, the remainder must be equal to 0. So now we have one equation, 2a plus b equals 5. Let's divide the quotient of the first division by x minus 1. 5a plus b plus 4. And once again, because this polynomial is divisible by -1, the remainder must be equal to 0. So we have another equation, 5a plus b equals -4. And let's solve these equations simultaneously to find the values of a and b. Therefore, a is -3 and b is 11. Number 4. In this question, we need to find both the maximum value and the minimum value of this function, sine 3x, given this domain of x. Let's have a quick recap about the sine function. The graph of sine x looks like this. How about the graph of sine 3x? Sine 3x completes its cycle 3 times as fast as sine x. So it's going to look like this. 1, 2, 3, 4, 5, 6. And now let's think about these two values. What is sine 3 times 5 over 18 pi? 5 over 6 pi. This is equal to 1/2. And what is sine 3 times 2 over 3 pi? This is equal to sine 2 pi, which is 0. Now 2 over 3 pi should be here. How about 5 over 18 pi? Let's divide pi into 3 equal portions, and then each of these portions into 3 equal parts, and then divide each of these portions into 2. So 1, 2, 3, 4, 5 should be somewhere around here. So we are interested in this range. So the maximum value should be here, which is 1/2. And the minimum value should be here, which is -1. Number 5. Cosine 1/3 times pi is 1/2. Sine 1/3 times pi is √3 over 2. Therefore, z can be expressed as 1/2. The square root of -1 is I, √3 over 2 times I. So this is going to be a very long and tedious calculation. What is z squared? Next, what is z cubed? What is the coefficient of the second term? So z cubed is -1. Next, what is z to the 4th power? So z to the 4th power is -1/2 minus √3 over 2 times I. Finally, what is z to the 5th power? So z to the 5th power is 1/2 minus √3 over 2 times I. So let's add them up. 1/2 minus 1/2. 1/2 minus 1/2. This and this will cancel out, and these will also cancel out. So we are left with -1. Therefore, the answer is -1. Number 6. we need to make a pyramid using these 3 parts. So the base has to be S, and the side with the length of 1 must attach to this side, like this, and this side with the length of root 2 must be adjacent to this side, 1, root 2, and root 3. And this side can only be attached to another side with the length of root 3, root 3, 1, root 2. So we have 1, 1, and root 2. If we put these 2 sides up, the pyramid will look like this, or like this if you look at it from this angle. What is the formula for the volume of a pyramid? B stands for the area of the base, and H is the height of the pyramid. So B is 1 squared, and the height is just 1. So the volume is 1/3, and this is the answer. Section 2, number 1. So we have y equals x squared, and there's a circle inside the parabola, and we need to express a, b, and r in terms of t. So first of all, because the parabola is symmetric with respect to the y-axis, the x-coordinate of the center of the circle must be 0. So a must be 0. Next, let's think about the tangent that goes through the point of tangency. The slope of this tangent can be found by differentiating the equation of the parabola. And to find the slope of the tangent at the point of tangency here, we must substitute x equals t. So the slope is 2t at this point. And from this information, we can deduce the slope of the normal that goes through the point of tangency and the center of the circle, because the tangent and the normal are perpendicular to each other. 2t times the slope of the normal is minus 1. So the slope of the normal is minus 1 over 2t. Next, let's try to express the slope of the normal in another way. The slope of the normal can also be expressed as t squared minus b over t minus a, which is 0. Therefore, these 2 expressions express the same thing. So minus 1 over 2t equals 2 squared minus b over t. Multiply both sides by t. So b can be expressed as t squared plus 1/2. And finally, let's try to express the radius r in terms of t. The radius r is the distance between these 2 points. So r is the square root of t minus a squared plus t squared minus b squared. Now, we know that b is equal to t squared plus 1/2. Therefore, the radius r is the square root of 2 squared plus 1/4. Section 2, number 2. So in this question, we are told that the value of t is 1/2, and we need to find the area here. I looked at this trapezium here. So we are basically calculating the trapezium minus the sector minus the area under the curve. So let's first of all calculate the area of the trapezium here. The length here is b, and b is t squared plus 1/2, and t is 1/2. So 1/4 plus 1/2, which is 3/4, and the length here is t squared, which is 1/4, and the height of the trapezium is t, which is 1/2. 1/2 times 1/4 plus 3/4 times the height 1/2. So the area of the trapezium is 1/4. Next, let's calculate the area of the sector here. The radius is r, but we don't know the angle theta here. So let's use the right triangle here. Theta, the angle that we want, is here, and we know that the length here is equal to t, which is 1/2, and sine theta is t over r, which means that theta is inverse sine of t over r. So what is t over r? R is the square root of t squared plus 1/4. 1/4 plus 1/4. T over r is 1/2 over root 2 over 2, which is root 2 over 2. So what is inverse sine of root 2 over 2? The angle is 45 degrees, or pi over 4 in radians. So what is the formula for the area of a sector? The area is theta over 2 times r squared. So pi over 4 over 2 times t squared plus 1/4, which is 1/4 plus 1/4, or 2/4, which is a half. So the area of the sector is pi over 16. And finally, let's calculate the area under the curve. So the area under the curve is 1 over 24. 1/4 minus pi over 16 minus 1 over 24. So we need to multiply the answer by 2. So the answer is 5 over 12 minus pi over 8. Section 3, number 1. In this question, we are given two functions, f of x and g of x, and we need to find the derivatives f dash of x and g dash of x. You need to know the following formula. So let's apply this formula to the right-hand side of this equation. Inverse tangent of 0 is just 0. And what is the derivative of inverse tangent? So this is the answer to the first part. How about g of x? Inverse tangent of 1 over x is pi over 2 minus inverse tangent of x when x is greater than 0. So now we can differentiate this. G dash of x is minus the derivative of the inverse tangent of x is 1 over 1 plus x squared. So this is the answer to the second part. Section 3, number 2. In this question, we need to substitute x equals 1 into the function f of x, which is basically calculating inverse tangent of 1. Recall that when tangent x is equal to 1, the angle x is pi over 4, or 45 degrees. Therefore, inverse tangent of 1 is pi over 4. In this question, we need to add the two functions. F of x is inverse tangent of x. G of x is pi over 2 minus inverse tangent of x. Therefore, the sum of the two functions is pi over 2. we need to find out what happens to the function when x approaches infinity. To visualize this question, let's draw a quick sketch of the function. What does the graph of inverse tangent look like? Recall that the graph of tangent looks like this. Therefore, the graph of inverse tangent looks like this. Therefore, as the value of x increases, the function approaches this horizontal line. What is the value of this line? Remember that one of the asymptotes of tangent here is pi over 2 or 90 degrees. Therefore, this asymptote is also pi over 2 or 90 degrees. So the answer is pi over 2. And this is the end of this exam. Let me know if you have any questions and see you next time.